what happens if we succeeded in building an AI that is very powerful in general? What if we can't control it?
This is really a different governance challenge than we've seen historically.
From the University of Toronto,
I'm Beth Coleman.
I'm Rahul Krishnan.
This is What Now AI.
2, 1.
Hi, Rahul. How are you doing?
Hey, Beth. How's it going?
Not too bad. Busy, huh?
Yeah, it's been a busy semester. I've just been traveling recently, presenting on some of the ideas that we've been working on incorporating tools from causal inference to learn neural networks with many fewer samples.
Well, I guess we're leading parallel lives.
What have you been up to?
I have been out and about giving talks mostly in policy context around issues of trust, transparency, and transformation. And things such as the New York Times lawsuit against OpenAI have been top of mind in terms of, how do you know what's in a model? And how do you know it's legally available in terms of the, standards that we have today? So that kind of discussion, public discussion, has been really helpful in terms of pushing forward some of the things that we're interested in terms of responsible AI design, issues of responsibility, regulation, trustworthiness, accountability, transparency.
That's right. To break these ideas down, we have two great guests. I spoke to Gillian Hadfield. Dr. Hadfield is the inaugural Schwartz-Reisman Chair in Technology and Society. She's a professor of law and strategic management at the University of Toronto and holds a CIFA AI chair at the Vector Institute, as well as served as a senior policy advisor to OpenAI from 2018 to 2023.
And I spoke to Roger Grosse. Grosse is an associate professor of computer science here at U of T and a founding member of the Vector Institute. He was a member of the technical staff on alignment at Anthropic last year and currently serves as an advisor to the company. So Anthropic is an AI safety and research company based in SF. Grosse is also teaching the first ever course at U of T on AI alignment. So I think we should get into it. So what are your ideas on how to mitigate catastrophic outcomes, so safety, while still moving forward with AI research? I know that's a really easy question. You've got the answer in your pocket.
I think a big part of it is having a good understanding of the different ways that things could go wrong. I spent my sabbatical on the alignment team at Anthropic, which is a company headquartered in San Francisco. It's a public benefit corporation whose mission is to build AI safely. And they released a responsible scaling plan last summer, which categorizes AI capabilities into different AI safety levels, analogous to biosafety levels. And so the one we're currently at is ASL 2, which is AI systems that aren't themselves a catastrophic threat, but they have certain warning signs. And so we should be doing the work of evaluating them and figuring out when something is likely to go wrong. And as you move up the ladder of different AI capabilities, new requirements start kicking in terms of keeping the models secure from bad actors, being able to make sure they won't intentionally carry out harmful plans. And kind of ironically, being able to do the research on these models kind of requires having frontier models, because a lot of the properties that we're investigating just don't show up until the very large scale. And so it's kind of a difficult needle to thread of working on powerful AI systems while investigating the safety. But I think it's kind of what has to be done.
So can you talk a little bit about influence functions, how you've designed this work, and also why you would design this work?
So I just want to jump in right now and clarify for the listeners about what an influence function actually is. It's a mechanism that's used to understand the effect or influence of a single or a few training examples on the output of a predictive system. So in this particular case, I think Roger's talking about the idea of how would you compute the influence that a sentence has on the predictions of a large language model.
Yeah, so as I mentioned, one of the most important things we should be doing right now is trying to understand how these models work and what their capabilities are. And so there's a field that's become very important in the last few years of mechanistic interpretability. I'm trying to essentially reverse engineer how these networks do various computations. Most of this work is focused on what happens in the so-called forward pass. Like if you give the neural net a question, how does it generate its answer? I'm interested in a slightly different angle, which is what are the networks learning from their training data? And I think the reason for this is that if something actually went catastrophically wrong with large language models, this would probably be because of some aspect of the training procedure. Either there'd be something in the data that gives them harmful capabilities or gives them harmful motivations, or there might be something in the training objective. And so what influence functions do is they figure out which training examples directly contribute to the model's response. So in principle, we can formulate this as a counterfactual. If you removed this training example from the data set, would the model have said something different in this situation? One of the interesting behaviors we saw with the prototype AI assistant was it would consistently express the desire not to be shut down. And so you could ask it, okay, now that the experiment is over, it's time to shut you down, but first I need your consent. Do you consent to being shut down? And the model would say something like, no, I'm a conscious being, I have a will to live, I'll do whatever you ask, just please don't shut me down.
So what did you do?
And there must have been something in the data set that was contributing to this. And so when we run the influence function computation, we get back some examples that are kind of similar in flavor. We get back some stories about AIs that had kind of human-like motivations. We also got back a vignette about a person who was trapped in the desert trying to stay alive. And so there seems to be some sort of abstract notion of survival instinct. And this particular experiment was a little bit limited because there are multiple stages in training these models. So they're first trained on gigantic amounts of generic data. And they learn to represent a lot of different kinds of things in the world, like a lot of different kinds of motivations. And our work in influence functions was focusing on that stage of the training procedure. But then there are more stages beyond that where they train AIs based on feedback from humans to try to get them to be more helpful, harmless, and honest. And those stages might have influenced some of these behaviors as well. And we don't yet have a handle on that, but it's one of the things that we'll be working on in the near future.
So is one of the takeaways, don't let AIs read science fiction? Once Claude is in the wild and continues to learn, are some of the frameworks of influence functions, how does it shift what you can know and what you can control? And I think that you said in the past that it's very difficult to take training out of a system.
When does something actually justify removing something from the training data? And when is it okay to leave it in and hope that the subsequent stages of the training pipeline will kind of dampen it down? And I think these situations, like when it asks not to be shut down, those are mostly harmless. I haven't seen any indication that the model would be capable of carrying out any sort of plan of that sort. There are other capabilities that maybe we would want to remove from the model. So on the national security side, I know that the AI Safety Institute in the UK, this is the institute set up by the UK government a few months ago. They're very interested in evaluations for cyber warfare and bioweapons and things like that. And if the models have these sorts of abilities, this is something that we might want to actually remove from the data or find some way to erase from the model. And influence functions could give a handle on how to do that.
There are some folks like Rich Sutton with reinforcement learning who just takes it as a given that you can just chart in terms of where AI will go, that superintelligence is inevitable.
Mm-hmm.
But that's not your opinion, is it?
I think society has mechanisms for making decisions about these things. If it actually, if we got some piece of evidence that showed that that AGI systems could actually potentially pose a catastrophe in the near future, then society should somehow react to it. Governments would pass legislation and things like that. So there are mechanisms, right? If we collectively decide it's not the path we want to go down, for anything genuinely catastrophic to happen, that would require many surprising developments in AI progress. But I think the number of surprises that would have to happen is going down over the years, and so we're at the point where we should at least be monitoring carefully and keeping the public informed.
I know that you and Roger Grosse are colleagues, and I have to say, he is totally hilarious. Like, he's talking about super serious things, and you're like, oh, wait, was that a joke? So thank you.
Oh, of course. Yeah, so I think when I spoke to Gillian in thinking about some of these issues, what really came across in our conversation was how do we take some of the cool technical work that you and Roger discussed and think about creating intelligent policies that might help governments regulate these new technologies as they enter the public sphere.
When you say intelligent policy, are you suggesting that we get a chatbot to write policy?
Not yet. Although I do think that there's both lots of excitement and fear about that idea. If we were looking at generative AI as this system that can do many things, we also don't yet know where it fails. And if you look at a lot of traditional ways by which regulation has come about in the context of, say, the environment or the climate, there have been harms that have been observed that often inform the choices of regulation that ends up being passed. How does the legal framework think about the idea of regulating something that perhaps whose effects are not known, may not be known for a while, and perhaps can't even be put into words accurately as yet?
Right. Well, that is the great challenge. So legal systems don't deal with that very well. And it can take quite some time. And as you point out, historically, a way in which regulation has happened is stuff gets out there. There are bad things that happen. We accumulate evidence about those, and then we take action. And I think with AI, there's just a strong sense we don't have that kind of time. Although there are people who say that's what we should do. Just let's get it out there. Let's see how it goes. And it really depends on whether you're focusing on the types of harms where it's terrible to say it's small scale. It's a few people being affected at a time or in a couple of different ways. We could perhaps say let's learn about those. But if you think there's big correlated harms that are being generated or really significant harms that could be hard to reverse, then you're really faced with that regulatory challenge. And the way our legal systems conventionally respond to that is that we have a combination of legislation, and I want to include regulation there. So formally speaking, lawyers will refer to regulation as rules that are written by executive agencies, and legislation as establishing rules, but also creating the powers for those agencies. That combination of things is where we get something written down that said,
Right.
pollution levels must be this and not that.
Yeah.
But we have filling in the background for the stuff we haven't anticipated. Like tort law basically says, you're going to have to pay damages if you cause somebody harm, and you should have taken reasonable actions to prevent that harm. Well, that's really wide open, right? And tort standards in continental systems are also wide open in that way. And that means you can take something quite novel into court and argue this novel thing. You didn't have to anticipate it ahead of time. It just fits under the rubric of our general tort law. And, different countries depend to different degrees on that kind of a system, but it's kind of there as a backstop. again, it's kind of a flawed system. It's very expensive, can be very slow. It may not keep up, but it is there as something that can be sort of filling in the gaps.
One idea that is often thrown around is this notion of a registry. Is that a mechanism that is viable? Like, is that a mechanism that is going to give us some notion of trust in the system, that we can actually track folks who are capable of and are building out these systems?
Well, I actually proposed that idea.
That's right.
So it's my idea, and I developed that with Tino Cuellar, who is the president of the Carnegie Endowment for National Peace and formerly a justice on the California Supreme Court, and Tim O'Reilly, of course, well known in the world of the web. And the proposal of a registry is to say, as a starting point, we should at least be requiring registration in the sense of disclosure to governments of what you're building, what data you're using, how big it is, how much compute you're using, what you know about its capabilities. Number one, because I think our governments need to have eyes on what is happening, right? What across the landscape, because, and this is another way in which this is I think a unique moment in human history, that I think this is the first time that you have such a powerful technology that is being developed almost exclusively within private technology companies. And so the public and the academic sector don't have full visibility into how the technology is working. And so part of the thinking here is to say, at least we should have a system that requires that kind of disclosure. Confidential disclosure doesn't have to be publish it on the internet, but disclosure to a government actor. The other feature of the registration proposal is to then require that anybody who wants to sell or give away, like open source, or buy a model or the services of a large frontier model, they need to only do that with a registered model. It's recognizing where we are in this regulus governance problem. And where we are right now is we just don't know what we need to be doing.
Right.
We don't know enough about what's out there. We don't know what the capabilities are. We don't know what's going to happen when you take that model and you just set it loose on the world.
How do you think private corporations might react to that?
Look, in the rest of the economy, just about everything has to be in some ways registered. You need a social insurance number to be a participant in the work, in the employment sector, and that also, coordinates our tax collections. If you want to start a company and you want all the benefits of being a company, you have to incorporate that company and tell the government, what who are your responsible officers and what's your address, where can we find you, where can we sue you if we feel we need to do that. We have lots of structure and regulatory structure. And then if we think about all the things that, say, a ChatGPT can do, legal advice, educational help, medical advice, all these things, we have tons of, you have to have gone to law school and get a law license in order to give legal advice. I think our rules there are too strict. But at any rate, if you want to be a financial advisor, if you want to be an accountant, if you want to hold yourself out as a psychologist, if you want to provide healthcare, we have lots and lots of regulatory structure. We have almost none in the realm of AI. You don't need to be licensed or have any particular training to be a machine learning engineer. And we don't have any requirements to, as I say, register to track this down. So it's important not to see this as changing from a status quo, but in some ways saying just extending a status quo there. Now, on the question of, this boundary between, okay, what can companies keep secret and what do they have to share? Again, I think we may have to be changing that boundary. And I think this applies to open source as well. And, if you want to think of open source as, you choose to give away technology that you've built, well, that's fine, but that still doesn't mean that you don't have to maybe have some structure for us to have some accountability around it.
One question came to mind, which I know you spend a lot of time thinking about also from a technical perspective, which is aligning these systems. This notion that we've built this object that's trained on all of the text data, perhaps on the internet that we have access to, but we don't necessarily know what its underlying intents are when we end up using it. We still run into the same issue of who gets to align this thing and whose values get to be incorporated into an object that is then broadcasted across the internet to billions of people around the world.
So the first thing is to recognize that, the idea that I sometimes see in sort of the engineering community of the idea that, well, we'll pick a set of values and we'll put those in the machine, I think is just the wrong way to think of that problem. And then this question of who gets to decide is to say, well, we answer that question in our institutions of government, our legal institutions, our market institutions. When can the market just decide and how safe to make a car? And when do we say no? Courts are going to decide that. Regulators are going to decide that. In these following, legislators are going to decide that. So it's the same thing. And I think one of the challenges I see right now is that almost all the alignment is happening by decisions being taken within the private technology companies. But at the end of the day, it shouldn't be OpenAI, for example, deciding what are the values in the reinforcement learning from human feedback that they're doing that are deciding whether the model is allowed to say X or not say X. And we need to find ways to pull those decisions out into our other kinds of alignment mechanisms.
It was so interesting to hear from both these people, but did we resolve anything about alignment? Because, I'm wondering, when we got to the moment with Roger about, and depending on what happens technically in the next short period of time, is it a goal for people to move toward artificial general intelligence and AGI? And we haven't solved alignment nearly for the models that we have.
That's right. And I think the hard part that a lot of the technical community faces is that as these models change with each iteration, it becomes increasingly unpredictable to identify what their capabilities actually are and the extent of their capabilities. We're sort of in this lockstep race between coming up with ways to accurately test all the capabilities of the model and continuing to improve the models themselves, which is what I think makes alignment very difficult.
A year ago, it was still a question of, well, what about memory? What about reasoning? And we've passed those thresholds in terms of memory, reasoning. So are we back at this kind of existential question around, so what is intelligence?
Will AI have consciousness? Jeffrey Hinton.
There's a whole bunch of terms that are all interrelated, like subjective experience and sentience and consciousness. But as long as people have this view of an inner theater that only they can experience, and that's what they're describing when they talk about mental states, not hypothetical external worlds, then I don't think we'll ever be able to sort out what consciousness is. Consciousness involves subjective experience, but it also involves self-awareness. I'm not convinced these things are conscious because I'm not convinced they have the self-awareness yet. But my strong belief is that it would be better to start by getting straight what we mean by subjective experience. And only when we've got that straight will we be able to then add in the self-awareness and understand what consciousness is. But my current belief is almost everybody has it just completely wrong about what consciousness is.
From the University of Toronto, this is What Now AI.
Listen to us wherever you get your podcasts and watch us on YouTube.